to the Distributions Dev Room. Our first speaker this morning is, no, don't undo typing. Our first speaker this morning is going to be Andres Shadura.
Andrew.
Butchered it, I apologize. Andres Shadura, who will be presenting Managing Build Infrastructure of a Debian Derivative.
The talk is being recorded?
Yes, the talk is being recorded. The video has been set up and his microphone has been unmuted. It requires no human interaction.
You sure about this?
Looks like it's only
Pointing at the wall.
on the door.
It's supposed to be pointed directly.
Well, wall is also quite a nice thing to see.
You are correct. You are in front, sir. Thank you very much.
Maybe I get a t-shirt or something.
Speaks to fine folks at Please.
Okay, so I don't need to present myself once again, but I will do this anyway. So I'm Andre, and I'm a Debian developer, I started using Debian around 2006, and very soon I understood that, well, Debian is great because of the contributors, so I started contributing myself, at first by sending bug reports, then patches, and then finally I started maintaining some packages on my own, and in 2013 I became a Debian developer, and started maintaining even more things in Debian. And then 2 years later, I started working for Collabora, an open source consultancy, and which is great in a way that we were doing lots of fun things with open source in our work time. And at Collabora, I started working on a project which is called Apertis, about which I will talk today. And just some background, I never run any Debian infrastructure in my life, even though I've been part of a Debian project for quite some time. And so I've got no idea how to run like proper things like build D or deinstall and other things. Because when I started working on Apertis, I had to manage quite similar things, but not based on normal Debian software at all. Right, so Apertis is a Debian derivative distribution, which is based, in fact, not just on Debian, but on Ubuntu and a bunch of other packages we've developed ourselves. It's been originally developed for automotive purposes, in particular entertainment systems in the cars, but since then the focus has been shifted to all sorts of other onboard computers in cars. As a part of the project, we provide lots of infrastructure for development based on Apertis, which means code hosting at the moment is Segit, but we're planning to migrate to GitLab soon. Backtracking system, code review, at the moment it's Fabricator. Of course, package build services, image generation services, and automated testing based on Lava. About which I was going to talk as well at FOSDEM, but unfortunately my talk wasn't accepted. So Apertis is mostly based on Ubuntu at the moment, so we're a derivative of a derivative. We take a bunch of packages directly from Debian, most notably systemd, dbus, and some other things. And we've developed a few software frameworks of our own, APIs and other software packages. So as I mentioned, we use systemd for process tracking and application lifecycle tracking. We started using AppArmor many years ago when it was just a new thing in Ubuntu only. So this was one of the reasons we used Ubuntu, because they were upstream for AppArmor. About a year ago, I think we've migrated from Xorg to Wayland for graphics, and we've been using GStreamer for multimedia playback since the beginning. In Apertis, we use Flatpak and OS3. So the application bundle format is based on Flatpak, which itself is based on OS3. It's not quite the same thing as Flatpak's bundles, but we plan to migrate to actual Flatpak and not a solution based on Flatpak soon. We have an update system based on OS3. Originally we had our own system based on Btrfs snapshots to make sure that updates are atomic, and we've got recovery modes and so on, but because of certain drawbacks of Btrfs, we developed our own system based, we've developed a system based on OS3. So a couple of more details. So first of all, the Btrfs system had significant maintenance effort because we had quite lots of custom code based around working with Btrfs snapshots. Then our bootloader didn't support Btrfs, so we couldn't use it on /boot, for example, and other file systems which had to be something else. With Btrfs, we needed to use initramfs at all times, which isn't the best thing sometimes in embedded systems. And because the updater directly manipulated Btrfs volumes, it was unsuitable for example, unprivileged containers. And then with Btrfs, testing was a bit difficult, and Btrfs itself has quite a lot of issues which are being tackled, but still, like, it's not, I myself don't consider it a really production-ready system. So in comparison, OS3 works with any file system at all, any file system which supports Unix semantics. You can store multiple trees in the same repository, which is definitely a benefit, and you don't need extra partitions for upgrades, so it saves quite some space. Because it's a more complete solution on its own, we have less custom code, so the maintenance is much easier. And because it's a user space solution, it works better with containers, and we can use it with unprivileged containers as well. So some people may ask the question, why are we using this crazy mix of Ubuntu and Debian and not just Debian? Because, you know, Debian is great, universal, and obviously it's free software, and it's a community, not a company. So, well, despite all of those great things about Debian, at the moment when Apertis was created, there were certain issues with Debian. Most importantly, if there are people here who ran Sarge, for example, they may remember that it took, I think, 4 years or about that to get it released. Because in Debian the policy is the release is when the release is ready. There's no, until recently there wasn't any particular timing employed. So if there were too many release critical bugs, the release might be delayed even years. Since then it's changed, but when Apertis was created, it was still an issue. And then stable, it's a bit too stable for many people, and you know, with the frequency of releases, it means that you get updates only once in 2 years, and it's not always what we want. And then with unstable, things may break too often. And well, I myself broke unstable 2 weeks ago when I updated one of the key bits of it, which is POSIX shell. Unfortunately, I didn't do much testing, didn't do enough testing, and I uploaded something which was broken for a couple of hours until I uploaded the fix. And a couple of people, well, quite a few people ran into this issue, and well, it's been resolved since then, but this is an example of what may happen in a stable, we cannot use it directly. You can pull all of the updates from there. So Ubuntu, on the other hand, has also quite a large install base because, well, lots of people who are too lazy to run Debian, they just run Ubuntu, for example. So there's quite a lot of testing despite more frequent releases. So Ubuntu is an upstream for AppArmor, which was quite important when the apparatus was created because we heavily rely on AppArmor for privilege separation and security. And well, they've got regular timed releases, and they also had an LTS when apparatus was created. So these days we've got LTS in Debian as well, but back then it wasn't yet like that. So there are a couple of downsides. Obviously, apparatus is a derivative of a derivative. Oh, what's going on? Oh, yeah. So this complicates upgrades and rebases because, in every release of Ubuntu, there's quite a lot of updates coming from Debian originally, and when we are rebasing to a new version of Ubuntu, it just this impact amplifies. And then we don't really need all of the things we have on Ubuntu, like Mayor, for example, and other things. So it doesn't add any value for us because we use Wayland. We don't even use Xorg anymore. I think there's a slide missing. Anyway, so we are currently reconsidering this decision, and we might change back to Debian because lots of issues Debian had when the decision was taken are no longer issues, and it might make sense to rebase to Debian LTS, for example. Right, so now a bit more about the infrastructure we have. So the core of it all is Open Build Service, which builds packages in controlled environments and maintains repositories from which we create images and the updates and so on. This code hosting and review tool, at the moment, it's a combination of Cgit and Fabricator. But we'll be using GitLab quite soon for code hosting and probably for reviews as well. We pull a few packages directly into our Git, like systemd and dbus, so that we can apply our patches to them if needed, or we can use newer versions from Debian. And the rest goes, like the normal packages from Ubuntu Debian, they go directly into OBS. But I'll tell you more about what OBS is and how we use it in a moment. So OBS, every time it needs to build a package, it creates a fresh root of apparatus in this case, builds a package there, and publishes the binary packages, the debs, in an internal repository. So all of the source packages are version controlled. The system resembles Subversion in a way because it doesn't handle like proper branches like in Git. You can create branches, but it's basically just a copy with some version information, which you can build packages in their own space. They are not published in the normal repositories, so you can test how things work in the branch. And well, it has quite some fine-grained access control tools, so you can let your users. Some users can just read packages, some can commit, some can do reviews, and so on. But well, a bit more information on OBS was in the talk of Andrew yesterday. You can watch it online. So the apparatus is split in multiple components, which are target, development, helper libs, and so on, and importantly, snapshots. Each of them is a OBS project on its own, so it's more or less independent from others. in OBS, projects can use each other for builds. So, for example, here development can depend on packages from target, and SDK can depend on packages from development. This means that if the packages in development require dependencies to build from target, they are installed in the root by OBS and used. But normally not other way around. So an exception of this is basically target, because target needs some packages in development to build. But basically this split is mostly for images. We have separate target images, and we don't want development stuff like GCC in them. So while GCC can be used for builds, it's not installed in the images, so it naturally goes to development, not target. But Linux kernel is obviously in the target. So when packages get built, they are published in an internal repositories in OBS, which are not in apt formats, but they're used for OBS itself to build other things, basically. So when your package is dependent on something else, OBS internally fetches the dev package and pre-installs it in the truth. But for apt, we use RepRepro, which takes packages from OBS internal repositories and publishes them in a format apt can understand. In OBS it's quite easy to do full distribution rebuilds by just adding one more repository to the project. OBS starts rebuilding all packages in this repository, and they go nowhere. They stay in the repository, but they're not published in the actual apt repositories until you explicitly ask OBS to do this. And well, it's quite a tiny screenshot on this screen, but basically you can add as many repositories in OBS you like, and you can select you can tell OBS which other projects it depends on what architectures to build for. As you can see, we don't support i586, for example, or ARMv6. Right, so as I mentioned, the packages to which we apply no changes relatively to Ubuntu or Debian, they go directly to OBS. We just import them with no changes. Some packages where the patches are trivial, like, you know, fixing minor tiny things, we maintain them directly in the OBS using the OBS version control system, and we just apply patches, drop them in the Debian source package, and increment the version so that we can see where we have local changes. And we use a fork of Ubuntu's Merge-O-Matic tool, which pulls new updates from Ubuntu and does automatic merges when it's possible. Then packages where this approach doesn't work, we keep them in Git and use Git for merges and other things, so that we don't rely on Merge-O-Matic at all. Those packages, like I mentioned, systemd, dbus, and Mesa, and so on. So for non-apertus packages from Debian and Ubuntu, we use deb14 format from Debian. So we have upstream and apertus namespaces for tags and branches. Obviously, when we try to reuse the Git repositories from Debian, so we also have Debian/something tags and branches in the repositories normally, and we use Git build package and gbppq to manage the patches in the repository. You can read about them in one pages for Git build package. Basically, I won't go into details. And for native apertus package, we use a similar scheme. So the master is like the version in the current release, and there are branches for previous releases like 17.12, and we normally, it's an approach which is not accepted in Debian usually, so we keep the Debian metadata, the packaging stuff, in the master, not in a separate branch as normally is done in Debian, because it just adds some maintenance burden for no reason. And we normally just put tags on those branches for the releases. The version numbers are normally like 0 and then the release number, and they just increment. So Jenkins builds every commit on those branches in a controlled environment. If the build succeeds, it commits the result to OBS, and OBS creates merge requests and builds it in a proper route, which we then review and merge. We use a tool called Build Snapshot, written by Simon, which just creates releases out of Git branches, and if it's work in progress, not tagged as a proper release, it just builds a package which has the this funny Git revision number in the version, so that we can see its development version. And well, every time new patches are submitted at Fabricator, they also get applied and built by Jenkins. So until recently, we used linear image tools to build images. It was split in multiple stages. I will talk about this later. But linear image tools proved to be quite difficult to use and maintain. So we've changed it to our custom tool called Debos, which does the process much better and reliable. So this was the original scheme we used. So we had this separation between system hardware dependent and independent parts. So OS pack was basically a tarball with the root file system, not including any hardware dependent things. And hardware pack was the kernel, firmware, and other things, and we would combine them into images like this. So with Debos, Debos is a tool written in Go, which is basically Debian OS image builder. With Debos, we split the build process into stages in a YAML file, and every stage does like its own thing. And you can use templates similar to Jinja 2 basically, and select parts of it depending on the type of the image. It's a really cool tool, and written by Short, Simmons, and Denise Pinkin basically, and here you can read more about it. So in this tool, we got rid of the hardware packs as such. We still use the term, but it's actually just packages and files installed into the images when they're built. We also generate sysroots for software development kit. And then the Jenkins jobs, they trigger tests in Lava. And when the images are built, it also goes through the Fabricator and closes the bugs which were fixed in the images. So this is how it looks in Jenkins when it's all green and happy. So there are quite some challenges working with all this because, well, obviously a Merge-O-Matic cannot handle anything more complicated than just a couple of patches applied locally. Git does help, but we cannot put all things in Git, so we need to decide what can we do, what can we put in Git and what have we maintain manually. Removing all packages is quite tricky sometimes because you need to check what's going in Ubuntu and Debian and so on. And there are a couple of more issues with OBS basically because OBS is not Debian, Debian stuff, and it doesn't do the same things with building. Well, as I mentioned, we're going to migrate to GitLab soon and become a common platform for automotive systems and not just infotainment. And to learn more, go to aperture.org, and there's a wiki where you can read those things and learn more about the system. This is it.